Hey there laser folks! You are trying to measure the average power of your laser and wondering what beam size you should be using to get the most accurate measurements. I'll explain everything you need to know in this video. Welcome back. I'm Myriam from Gentec-EO, your partner for accuracy. A quick guideline is that your laser beam should cover a minimum of 10% of the detector active area, but no more than 80%. In an ideal scenario, your beam would cover 50% of the total active area. Let me explain these numbers one by one. Let's start with the minimum of 10%. This value is used to minimize the effect of special nonlinearities that could impact your measurements. The absorption of a detector at a certain wavelength is not perfectly uniform over the detector area. When you use a bigger beam on the absorber, all these nonlinearities are averaged out and you get a much more accurate measurement. The effect of special nonlinearities can be more obvious if the beam is not centered on the absorber. If you have a detector with a round aperture of 19 mm diameter, the minimum recommended beam size is 6 mm since 6 squared divided by 19 squared gives you around 10%. Of course, this doesn't take into account the minimal beam size required to avoid exceeding the minimal power density damage threshold of your detector. It is possible that your beam needs to cover more than 10% to avoid marking the absorber. If you are not sure about damage threshold, check on your product's datasheet or in the user manual. You can also use the calculator that is on each product's webpage. Under the specifications tab, you'll find a big blue button labeled "Check if this product works for your laser." Enter your laser parameters and submit. The tool will check wavelength, beam size, power density, and even energy density if the laser is pulsed. Now, let me explain why a maximum of 80%. Most laser beams have a Gaussian profile, so most beam diameter definitions don't include the region that we call the wings. 80% takes into account that the majority of the power distributed in the wings will be inside the aperture. The other reason is to avoid edge effects. If it is too big, there is a good chance that your beam will hit the housing of the detector. You want to avoid this at all costs, since power on the housing will create a negative voltage and reduce the power measured by the detector. Lastly, why is 50% of the area the ideal beam size? The answer is simple. It is the same conditions that we use here at Gentec-EO for calibration. Covering 50% of the active area will assure you that the total power of your beam is absorbed by the detector and that any special nonlinearities, if present, are cancelled. You now know the ideal beam size to use with your power detector. You can subscribe to this channel to find out more expert tips on how to achieve the most accurate laser beam measurements. See you next time. Bye!